Hello, welcome again. We are solving some questions of fluid mechanics and machine. The topic is viscous and turbulent flow. Question number 5 is the velocity profile of a fully developed laminar flow in the straight circular pipe as shown in figure is given by expression ur is equal to minus r square by 4 mu curly p by curly x bracket 1 minus r square by capital R square, where curly p by curly x is a constant. The average velocity of fluid in the pipe is option A minus r square by 8 mu curly bracket curly p by curly x, B minus r square by 4 mu curly p by curly x, C minus r square by 2 mu bracket curly p by curly x, option D minus r square by mu bracket curly p by curly x. So here uh, assume a small strip of thickness dr at radius r and the discharge through that strip is dq. Okay, so and velocity through that strip is u. So the discharge can be written as u into 2 pi r into dr. Okay, and the expression for u is given as this. Ur is given as this. Okay, so we can write u the value of u and then it will 2 pi r into r. Now to find out total discharge integrating this 0 to r. So now this is your dq and it is integration is 0 to capital R outer radius. So it will be now 4 mu is constant, curly p by curly x is constant, 2 pi is constant, as r minus r square into r dr is found. Okay, giving the integration. So this is r square r minus r cube. So it will be its integration will be r square into r square by 2 minus r4 by 4, or the limits are r and 0. So it will be minus 1 by 4 mu curly by curly x 2 pi r4 by 2 minus r4 by 2 by 4. Okay, so if so this can be so the expression comes out as pi by 8 mu minus curly p by curly x r4. So this is the expression for discharge. Okay, now to find out the average velocity we have to divide we divide it by the total area. So discharge is this, so if we divide it by total area then that is pi r square. So we'll get u bar as 1 by 8 mu minus curly p by curly x r square. So answer is option A. Next, the discharge of a viscous fluid having viscosity 0.097 Newton second per meter square through a pipe of radius 50 mm is 0.004 meter cube per second. The pressure gradient is given by option A 146.12 Newton per meter cube, option B 157.99 Newton per meter cube, option C 133.99 Newton per meter cube, option D 150.912 Newton per meter cube. So here we have derived the expression for average velocity and discharge, and discharge is this quantity. Okay, now mu is your 0.097 Newton second per meter square, r is your 50 mm, q is your 0.004 meter cube per second. So q is 0.004 and curly p by curly x we can find out by putting r is equal to this expression we have derived. Okay, so now we have all the value except curly p by curly x, so that is 158 Newton per meter cube. So answer is option B. Next, the velocity profile in a fully developed laminar flow in a pipe of diameter d is given by u is equal to u naught bracket 1 minus 4 r square by d square, where r is the radial distance from the center. If the viscosity of the fluid is mu, the pressure drop across a length of length L of the pipe is option A mu u naught L by d square, B 4 mu u naught L by d square. C 8 mu u naught L by d square. D 16 mu u naught L by d square. So u is equal to u naught 1 minus 4 r square by d square. Okay, that is given, and that expression we have derived. Okay, uh, 1 by 4 mu curly x r square minus r square. Okay, so that expression we have derived in the first question. So equating these two, so modifying it, putting r is equal to d by 2, converting it into this term. Okay, so by this, so doing some modification, we get d square by 16 mu curly x 1 minus 4 r square by d square is equal to this equation number 3, and this is equation number 1. Equating 3 and 1, so we get u naught is equal to d square by 16 mu curly x. Okay, 16 mu u naught by d square dx is equal to dt. So integrating this, we will get 16 mu u naught into L by d square P1 minus P2. So the pressure difference is 16 mu u naught L by d square. Option B is the right answer. Next, in a laminar flow, the coefficient of fracture is given by F is equal to 16 by RE. Then the head loss in the pipe across a length L is given by option A HF 32 mu u bar L by rho g d square. Option B HF 16 mu u bar L by rho g d square. Option C HF 8 mu u bar L by rho g d square. Option D 64 mu u bar L rho g d square, where mu is viscosity, D is diameter of pipe, u bar is average velocity, and rho is density. So the roll number is your rho v d by mu. Okay, and or in terms of average velocity is rho u bar by b. And for the laminar flow, F is 16 by RE. Okay, so F is you have 16 by rho u bar by mu. So head loss is given by internal is given by this 4F L by d square divided by 2g divided by d into 2g. So putting the value of F, we get that expression as 32 mu u bar L by rho g d square. So answer is option A. Okay. Next, the external and internal diameter of a collar bearing are 200 mm and 150 mm. Between the collar surface and the bearing, an oil film of thickness 0.25 mm and viscosity 0.9 coils is maintained. The power loss in overcoming the viscous resistance of the oil when the shaft is running at 250 rpm is option A 22 watt, option B 26.48 watt, option C 23.28 watt, and option D 22.12 watt. So here this is your bearing, and this is your shaft, this is your bearing, and in between there is a viscous oil. Okay, and let at any radius r in between the velocity is u, so that is 2 pi rn by 60 or omega into r. Okay, and the shear stress is given by mu d by 0, or we can write it as thickness of the thickness is t, so we can write as du by u by t. Okay, and mu change in velocity is u, and tau is your mu u by t. Okay.